What is the most used man-made material on Earth? You guessed right, it's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic Podcast. And today I have Matt McCombs from Intelligent Concrete. He's been on here before. So I think you're the first one that I've had on the podcast twice, man. So
really? Wow.
Appreciate that.
Hey, it's my pleasure. You do great service to the industry, in my estimation.
Oh, man. Wow. Thank you. Yeah. I appreciate it. So Matt and the Intelligent Concrete guru, John, we're having, I think it was a coffee talk, but one of your things on LinkedIn, and we were talking about cement, and I had some questions on the limestone cement, PLC, Type 1L, whatever you want to call it, and where it's coming from and things like that. And Matt gave me some good info afterwards in a message, and then I asked him to come on and share that information with our podcast listeners, and he agreed. So that's why we're here today. So I guess to start off, we were talking about I don't even know what we were talking about, but we got to the 1L cement at some point, and I had questions about the difference between domestic cement and imported cement as far as my understanding, Matt, and you can tell me if this is what you guys work with all kinds of folks across the country, is all domestic cement now? Is it all 1L now?
Not all of it. They're rapidly going that way. Unbeknownst to me, I thought by now all of the suppliers would have changed over, but apparently there's a few that still provide and will sell just regular Type 1 too. It's the same clinker as they've always made. They're not doing anything different really in the kiln. It's after the clinker comes out of the kiln and they're going to grind it up. Now they add more limestone filler to that process. And so each ton is now probably closer to 10, 11, 12% limestone that has been blended in after the clinker was produced. Whereas traditionally in the last, 5-10 years, it's been closer to 3 or 4%.
I got you. So you're saying those guys that haven't gone to 1L are adding limestone to it on top of it? Or are you saying these are the guys that are going to the 1L domestically?
So we'll just say all the domestic cement, producers are itching to go to all 1L, right? Because they can take the clinker that they've always made. They're not changing anything on that side of the equation. You got the clinker production, which is you end up with clinker balls, and they're then run through a milling process where they grind it really fine to make cement. And in that milling process, I like to get a masonry cement for putting up a block wall. You would have probably added and blended in maybe 15, 17% limestone. Mm-hmm. So this limestone rock they'll use on that end of the production process is usually it's what they've got to make clinker out of, but it usually won't pass. It isn't the best limestone they have available. They want to use the stuff that maybe has too much magnesium and maybe something that has too much of another mineral that they can't use to make the clinker. Because when you run it through the kiln, man, I'm all over the place here. When you run it through the kiln, it melts everything. And then when you melt it, all of those individual components are now, in a state of flux. And when it cools back down, if you have the right raw feed and the right heat, then it'll cool down into something that you can grind up and make really good Portland cement out of, right?
Mm-hmm. Yeah.
So if you have too much of one thing or another in your limestone, there's been a couple different cement suppliers I'm aware of that ended up, they couldn't use the limestone in their quarry anymore. They had mined down to a point where the mineralogy changed and they started shipping it in from somewhere else. It's critical because it's a majority of the cement is your limestone. So if they have a bunch of this off-spec limestone laying around, they have no other use for it, they'd love to grind it right back into the cement, and that becomes then part of the finished product that we all use. And since there's the decarbonization goals that have been created, they're trying to find ways to decarbonize their cement. So the more limestone they can put in the finished product, the less tonnage of clinker they produce to sell that, right?
Yeah.
And so, right now to go from a type 1-2 that we were using in Colorado, for instance, for a long time, which had already had some limestone ground in the finishing process, it was probably closer to 3% of the finished product. Now it's closer to 12%. So they just cranked up that dial a little bit
to offset the clinker, right?
Yep. So now let's just say if the market doesn't change, if the sales stayed consistent, they would produce the same amount of clinker in a year, same amount of CO2, same amount of everything, except now they sell more cement. And then your overall, when you look at that, we'll call it the numerator in the equation, since they sold more cement and didn't produce any more clinker per ton, then they become more efficient. They've got less carbon associated with that amount of cement.
And margins go up, wouldn't it?
Oh yeah, absolutely. There've been some incremental changes to specifications throughout the last decade or so that have allowed them to inch closer and closer to this. And then now with the Paris Treaty or whatever it was that's really got everybody in an uproar about, embodied carbon and whatnot. That's when all of them said, this is our opportunity to really crank up the Portland limestone cement, because it doesn't do as much as you would think to lowering carbon, but it does lower it some, and they need every advantage they can get. So that's why they really went all in. And we were told in 2021, end of 2021, roughly, by all the cement suppliers that, hey, by the end of 2022, you will not be able to get 1-2 cement. It's Portland limestone cement. And we started testing it then and working with them to hopefully, if we didn't like it, to try to get them to change it up a little bit before, their target date some point last year when they were going to make the changeover. And right now, I believe only one cement supplier in Colorado still sells the 1-2 cement. Mm-hmm. And they have it available for, I think, some specific customers. But other than that, that's all you can get is Portland limestone cement.
Gotcha. And when you say we were testing it, are you talking about the ready mix suppliers? They were taking the cement, making trial batches, and making sure things were coming up the way they should. I gotcha. I was curious, and I think this would be good for you and John to do on one of your talks, is if you guys could, the data sheet you get when you submit a mix design, and it has the cement. Yeah, it's got the cement. I'm a concrete contractor, dude. Sure. What the product data sheet for cement?
Right.
If you could explain all that stuff in there, I'm sure there's things in there that, like you were saying that how much limestone and different things that are in cement.
Yeah.
If you guys could share, break that down for us.
Sure.
That would be awesome. And then because I'll tell you right now, most of us, all we do is go, all right, it's in there. Good. Slap it in there with all the other documents that you're supposed to do for your mix design with your aggregate data sheet and all that good stuff. And it gets sent on to the GC, and we cross our fingers and hope the structural engineer doesn't ask us any questions about those things.
Right. And the concrete salesman that sent you most of that sent you probably 10 times as much shit as you need to send to the structural engineer. And I'll tell you what, I could summarize that mill test report for you. It's probably one of the single most useless sheets of paper in existence today.
I was worried about that.
It's like the culmination of taking every sample you make, blending them together, testing that one composite sample, and then saying, here's the test results. And our average production over the last 2 weeks has been, within the guidelines that we have to stay within, which you could fly a whole squadron of 747s through those tolerances. And it doesn't tell you anything about how the concrete's going to perform, other than it met some requirements which are fairly easy to meet.
The ASTM, right?
Yeah.
So does it matter? First of all, are those aren't third party tested, right? That's just done
in-house.
That's a problem. And then also, what was I going to ask you? So those are done in-house. Mm-hmm. So it's by the cement manufacturer. Oh, is there an expiration on that stuff? Because the one I just looked at recently, I could have swore that thing was 10 years old.
Oh my gosh! So let me back up. I think that sometimes you're going to get some certifications from a cement supplier or from a concrete supplier that's using a particular cement that may have been provided by some other lab, but all of the cement I'm familiar with, we've gotten the mill test report from the cement supplier that tested everything in-house, and then we submit that with to certify our concrete, is going to be good, right?
Uh-huh.
Yeah. And then what did you just ask? Because I forgot your
the mill test. Does that report? Is there a expiration on that?
Expiration.
Yeah.
Yes. They're supposed to, man, I can't remember, honestly, if it's by production or time. I think it's time. You should have one that's within it a year old, but they produce them every month. I believe, but they're required to have a new one every month or something like that.
I might be exaggerating a bit, to be honest with you, but I just remembered it wasn't a recent date. Right. I was expecting something recent, but I have to go back and look at that. But yeah, that'd be very useful. Even if you're saying that, I guess they don't test the cement like they're supposed to anyways. And then kind of like a ready mix isn't tested like it's supposed to when out in the field. So
right. Exactly like that.
Yeah. God, that's unfortunate. So, all right. So we were talking about domestic. We got into the imported cement, and I guess I put on my tinfoil hat for a second, and I was asking you if there was some kind of conspiracy on we're trying to somehow have another way for us to keep imported cement from hitting our shores. So I didn't know if there was any limestone cement imported. And I asked you about that, and what are you seeing?
Now, as far as what's being imported, I'm not 100% certain if any of it or some of it or what percentage of it is PLC. But if you've got a company like Holcim or Lafarge, they've got way more cement production overseas than they do here. I mean, U.S. is a very negligible cement producer when you compare to the world. So I don't know if that's what they're importing or not. I do know that we can get a lot of different cements from Turkey, India, China, that Greece that are not Portland limestone cement.
Yeah. Yeah. And that's happening still.
Oh yeah, absolutely. I mean, you just got to look for it, right? Find the people that have it. And I would imagine slowly they'll all start to inch this way, because if you're a cement producer, you just increased your margin by 8 or 9% if you went from good old faithful type 1, 2 to PLC.
Yeah.
Now, who doesn't want to have a margin increase like that?
Yeah. So what are so when I talk to suppliers and we're getting quotes from them, most of our projects are, longer term. So they're 6 to 12 to maybe even longer, 18 months long. And then we got to talk about, hey, what escalations are you going to have on that? And it's always a dance with suppliers to talk about what escalations are going to happen between now and then. And it's always cement. They say, hey, we got another cement escalation. And it seems like it's been like that for at least definitely the last 3 years. Definitely. Right. So are those cement increase in price? Is that due to this change? I'm sure it's more than that, but what do you know about, guess, those increases? So
the cement manufacturing process is hard on material, hard on your equipment, hard on your everything in that plant. That's some abrasive stuff. And so bear with me for a second. So they have a lot of maintenance to do. And when you went through COVID, a lot of these places either couldn't get the spare parts because people were shut down elsewhere in the world where they would get them, or they couldn't have people got sick, so they had a short staff. And concurrently, it was construction was never stopped in this country. As a matter of fact, that first year of COVID, we had a record year at Martin Marietta in Colorado as far as concrete production. We were we couldn't find enough raw material to make all the concrete. We needed another 100 trucks. So what I'm getting at is when they got into that kind of a deal where they were outrunning their preventative maintenance, and then they were outrunning their required maintenance, and then they had a complete shutdown because a major piece of equipment broke. All that stuff adds up and costs money, and that drove supply down a little bit and cost up a little bit. So some of those were related to COVID and have been for the last 2 years, right? Not this last year, but the 2 years before that. And right. Then now when you go to the PLC, it costs you less to make. So why would that result in an increase in cost? It's because now we're selling you a premium product. This is a environmentally conscious, sustainable option that we're forcing you to use, and we're gonna allow you to pay more for it per ton.
Right.
That was another one. And then there's other factors that I'm probably not even aware of that are driving the cost up. But we had more individual cement price increases in terms of how many we had in a year, and then the magnitude of each one. In that last 3 years, they've gone up a lot, and they've gone up several times. So that's, a big part of what's driving all of this is the fact that the cement, which costs more than any other product in your concrete by a long shot, is a lot more expensive now. And in Denver, it went up. It went up enough that concrete's going up from probably $135 a yard to $200.
Yeah. Similar out here on the East Coast. We're seeing the same kind of craziness. Because I at one time I looked at it. It might have been a year or so ago, and as historically, concrete went up like 3% every year, and then 2020 went up 10. It went up crazy, and then ever since then, it's just like I stopped looking at it. It's just like
it's depressing, probably.
Yeah, it is, and trying to explain all that to clients, and then remain. I guess the good thing is that everybody is dealing with it, and it's not just some of us. So, but it's. I guess my concern is that it seemed like we switched over to the 1L really quickly, and we don't have a lot of historical data on it and how it performs, and it, will it be be as sustainable as, and sustainable to me is something that lasts for a long period of time. You don't have to rip it out and replace it in a short amount of time. That's my concern. Not trying to badmouth 1L or anything like that. And just, I feel like, just like a lot of things in our world these days, we're rushing to use something that we don't have a lot of historical data on. But it seems like you can share what you've been seeing, but depending on who I talk to in the country, we've had mixed results so far. Locally, it sounds like it's been performing, but I've heard of folks like north of me having low break issues, and then down south, down in the southeast, I've heard some rumblings too of it not doing as well. But it just seems like there's so many different things that could, like you were sharing how it's manufactured, the 1L, the PLC, how it's manufactured, how many things could be going wrong there, but even before it gets to the supplier.
Right. Oh boy. Yeah. It's crazy because, we deal with uniform standards and specifications for the most part across the U.S. They're regionally, they're going to change if you're dealing with different DOTs, but we still have the same ASTMs for cement. And I'd mentioned you could fly a 747 through a squadron of 747 through those tolerances in ASTM for making cement. And that's what creates the big gaps in performance between different products. I mean, they all are trying to optimize a lot of different things when they make a cement. So they have a high amount of quality compared to their competitors, and quality is defined by the customer, right? So there's a lot of factors, but you compare your cements in Richmond to the cements in Colorado, to the cements in California, to the cements in Texas, to these imports, and you're going to get fairly wide range of performance. And then that's just in the lab. Now, when you go out to Realcrete in the field, that's when, screw the lab results. I want to know what it's doing out there. The finished product, is the quality of what's on the ground any different than it was before? Because I was told we're switching you to type 1L. All right. And it's going to happen within a year. And ironically, all 4 cement suppliers out here came up with this at roughly the same time. Now, if that doesn't raise, and I saw your eyebrow go up, you gave me like the people's eyebrow. How did this happen at once? But that's neither here nor there. But in Virginia, you've got humidity, right? So the concrete we're generally having the worst problems with is going to be flat work for the most part, or bridges that are static, and then they're getting a runoff from the road and the salts and stuff. But your flat work is got a wearing course. It's a wearing course. And people are going to walk on it, drive on it, whatever they're going to do. It's got to be, that top surface has got to be impeccable, as good as we can possibly make it. And with the Portland limestone cement in an arid region like Colorado, where the finishers already have a tough enough time dealing with the environment, the fact that you've got all that limestone ground in 10, 11, 12%, and less clinker, which is really the active ingredient. The limestone's an inactive inert mineral filler, and the clinker's still got the juice in it that's going to make the concrete set up, harden, gain strength, all those things. So if you've diluted that, in order to create somewhat consistent performance, you have to grind it all up a lot finer and make that clinker fraction of your ton of cement more reactive to cover up for this 10 to 12% of inert filler you just put in there. Does that make sense?
Yeah.
All right. So if it's finer, there's whatever, a fair amount of water in each cubic yard of concrete that's just water of convenience, and it's going to come out before this concrete hardens. Gravity pulls the denser material down and tighter on top of itself, and then it forces the lighter material out, which is the water, and you get bleed water, right?
Mm-hmm.
And so while the concrete's still plastic, it has no strength. We'd agree on that, right? It has no resistance to changes in volume or anything. So if it's sitting there and you've got humid air above it, it's almost like perfect condition for concrete, because everybody can take your time and we'll let the bleed water come out and then kind of go away and we'll finish behind it. Well, in Colorado, it's more like, holy shit, it's drying out. I've got no cream. The bleed water can't come out fast enough because the air is so effing dry already. And now you're going to give me a product that bleeds less. So that tells me that unless the finishers change a lot of things in how they're going about putting this stuff down and taking care of it while it's trying to set up, harden, and get the strength it needs to resist the aridity in the air, right? Then you're going to have problems with the quality of the surface, because if you deprive it of moisture, if it dries out, your cement hydration stops, right? It has to have water. And the opposite of that is, they've said like places like Soldier Field or the Hoover Dam have been around for a really long time. And although at one time their design strength was, we'll just say 3,000 PSI, they core it and the strength's actually closer to 8,000 PSI. And that's because it's had moisture supply for all that time. And all the cement in there just keeps hydrating and hydrating and hydrating almost infinitely, right?
Yeah.
Okay, so going back to my example, if you take that moisture away or if you take it out, right, then it won't continue to hydrate. It'll stop, and whatever strength you got at that time is pretty much what you got. And then we're talking about highways, streets, bridges, bridge decks, whatever it is. If you're even allowing a thimbleful of water to escape before that concrete has reached its target strength, then you're not doing as good as you could possibly do. And in a way, you're compromising the quality of that product. So we're doing all this work to fight for the environment and save the planet and all this kind of stuff. And we're focusing on the production of this Portland limestone cement, and everybody's giving themselves high fives and pats on the back. Meanwhile, nobody's done anything or very little to get the community ready. They haven't changed a damn thing about how we're going to take concrete, we're going to bid work by using this concrete, and we're going to make our living that way, and we're going to have the same people putting it down as we always have. How many crews have you seen change their practices to deal with this Portland limestone cement a little bit differently now than what they did before, or the way they did before, right? So it's, I think when you say rushing it or pushing it too quickly, absolutely, it happened quickly and way too quickly. And it had several groups across the country not stepped in and said, hey, hold on a second here. You're telling me the performance is the same between these two products in the cement industry? Oh yeah, absolutely, it's the same. Look at these lab results. I mean, shit, man, that's identical practically. You can't even tell the difference. And then we get it and we test it and we're like, dude, that isn't even close, man. It's very different. You cannot say that it's the same. It's not.
Yeah, it doesn't have the same ingredients. Right. But finishers have been. That's what people don't realize is finishers deal with that every single day. Not one load of concrete comes out to them the same, That's right. So they're constantly, but this is a whole different animal. Have you guys looked at curing these things differently or anything like that? Does that help? I have help the 1L, I guess, act more like what we're used to, type 1, 2, or is that a solution? I hate to sit here and bitch about something and not come up with fixes.
Oh, that's a fair point. Okay, so the industry in Colorado did a good job, I think, of teaming up and testing the shit and perhaps asking or pushing for some adjustments to try to make it a little bit more like more similar performance. But when you say curing, could that improve it? I don't know too many people that do a real good job of curing in concrete because sometimes it's almost impossible to do a good job. If you've got a 10,000 square foot slab and, it's a little bit, it's sunny today and then you got a breeze, are you not going to pour? Hell yeah, you're going to pour. But those two things make the curing a bigger challenge because you can't just go walk on it after you run your last finishing pass and then spray curing compound all over it or flood it immediately in the winter, right? I mean, you can't. So how do you do it? It's already a challenge. The challenge, I think, in the drier regions is leading up to curing. And I've never seen a finisher in the field in Colorado have 3 sprayers sitting out there ready to go, one with con film, one with an actual finishing aid, and one with a curing compound, right? Which is kind of what you need here because it dries out so fast, Seth, it'll blow your mind. You have a very, very little minute. This is the most challenging region in the world or in the United States to place and finish flat work. Absolutely, hands down.
Yeah.
And nobody has any of that stuff. But yes, you could do a lot leading up to the curing and through the curing process to make this stuff last better. We could have collectively as an industry probably done a lot better job before we made this change. But now we've made this change and it's got some drawbacks for certain.
Yeah.
And if people are getting low strength, you've also got to look at, there's a good chance it's just not setting up as fast in that area. And people were making this test cylinders and curing them the same way they did before and picking them up, and they have less strength when they do pick them up, just like they always have. And now they're perhaps getting beat up because the roads are shit on the way back to the lab, and they're rolling around in the bed of the pickup, and you're getting, lower compressive strength as a result.
Yeah. Yeah, we're producing lesser quality stuff.
We
possibly.
Are inadvertently.
Inadvertently, yeah.
Some of us, it's inadvertent, I think.
Yeah.
I think that, personally, the cement industry has been pushing for this like in an unorganized fashion for years. And the Paris Accord or the Paris Treaty or, the agreement that everybody's come, Architect Challenge of 2030 or 2050, that has to be related to somebody's goals and objectives at the top of one of these cement companies, because this is exactly what they've been waiting for. And now almost at the same time, all the cement suppliers, the major ones in the world, have said, hey, guess what? We're switching to type 1L because they made this challenge and we've got to lower our carbon. And this is one way we can do it.
Yeah. Because the alternative is being, I think you were sharing before we hit record, was optimizing your mix design and using less cement to offset your carbon emissions.
Right.
So rather than, I guess, putting the same amount of cement in it with less clinker.
Yeah,
right.
You're going about it. It's like, here, let us do that for you.
Yeah.
It won't change a thing.
Oh, man. Well, I don't think we're going to solve the cement issue today, Matt. But we'll have to but make people aware of it, and so that so they know what to look out for, and hopefully give the concrete suppliers and contractors I get benefit of the doubt. So getting handed some rough cards at the present moment, I think.
Yeah, it's definitely, anytime you make a big change, concrete industry is unique. Would you agree with that?
Oh yeah, they any club that allows me to be in it, it's got to be unique.
Oh, I'm going to tell you something. Me too. I'm right there with you, man. It's like all the comical characters, all of the knuckleheads, and it's kind of almost like I guess I went up to Williston, North Dakota for a couple months on a frac crew in between jobs, and oh my, that was the Wild West. It reminded me just like working in the concrete industry.
Yeah.
But shit, man, I mean, you can't effectively communicate to everybody, hey, here's a new product. This is the performance change. And starting tomorrow, you're all going to be using it. All right. So prepare yourself. That didn't happen. It was, hey, this is the same stuff. All right. It performs the same. We're going to change it. And if you're smart, you probably won't draw a whole lot of attention to it because you could put yourself at a competitive disadvantage. And so then it happened overnight and here we are. And people are talking about performance changes in material without adjusting something to accommodate it. And you're going to have some sort of a problem. Right. And you mentioned compressive strength. Well, we haven't been using it long enough, or even if we have in some areas, once we get through this winter and we start collecting information on, well, how did it do? How did it do in the field? I mean, did we have more tear outs than usual? Did we have more R&Rs? Did we have more, potholes? Did we have more people calling into the city council saying you owe me for an alignment on my vehicle because of all the friggin' potholes you got out on your street or joint rot? You're going to find that it probably didn't perform worth a shit. And we're going to have to go back to the drawing board. But unfortunately, it's going to take a period of time before people get back to what really changed, right? And it was the product.
Yeah.
And the finishers didn't change. The ready mix producers didn't change to some extent because it's still cement. We probably had to use a little bit more water reducer to get the same slump, or somebody just used water, one or the other, which doesn't help. But it's the cement that changed. And there's just no getting around that this is not the same stuff. And if you don't adapt to it, you won't get the same results.
Yeah. Yeah. Unfortunately, I think our memories are very short. So hopefully us doing things like this and we recording, people can go back and listen to this and go, oh, yeah, I remember when we did that. Maybe that was what
Yeah, you know what it reminds me of is whenever there's a concrete failure, it reminds me of a Monty Python's movie. I don't know if it was The Life of Brian, but it just kept going back to this group of people that wanted to stone a witch. And it didn't take anything just like this before the whole group wanted to stone somebody. Do you ever see that movie?
No, I never got into the Monty Python. I'm not into British comedy, dude. It's hard. Yeah, it never. Maybe it's the accent. I don't know. I can't get over it.
You seem like a dry kind of guy to me, so I'm surprised that you're not into that. But some people.
Yeah.
Anyway, the point being, it's like, a drop of a hat, there's a problem, and everybody grabs the lanterns and pitchforks, and they're going to go down to the ready mix supplier and burn down the place because that's their fault, right? Or whatever. And it trying to convince people of what actually occurred in order to produce the failing result is sometimes difficult. And people, I just anticipate, won't connect the dots very quickly.
No. I don't have any faith that we will connect the dots.
Yeah,
I think we're forgetting about the stuff that we did in like the early 2000s.
Right.
We're seeing those same things come up again, the P2P stuff, the Roman concrete stuff, all that stuff's being recycled right now. Right. It's about the length of our memories is that people are like, oh, no, we haven't talked about this before. Yes, we have. We have done this. We've gone through this. We're recycling the same new ideas. But, well, I think that's a good spot to end today. You know what the good thing is about this all going on, Matt? It keeps consultants like you guys busy.
Oh, yeah. I can't wait for the whole round of litigation opportunities to come out as a result of all this.
We need what do they call that? When they call you into
like a deposition?
Deposition, yeah. What do they call those people? When you're supposed to be the smartest person in the room.
Oh yeah, you're not a character reference, but you're like a materials expert or expert testimony.
Yeah, there you go. See, there's opportunities there.
Yeah, I tell you what, man, the words expert and concrete are mutually exclusive. All right.
Yeah, I know. But anyways, Matt, if folks want to reach out to you, give them the Intelligent Concrete plug.
Yeah, absolutely, man. Intelligent Concrete. If it's got to do with concrete, we can help you out with it. So it's intelligent-concrete.com. You can find us all over the internet, Instagram, LinkedIn, Facebook, just our webpage, www.intelligent-concrete.com. And through this podcast, I'm sure that they'll probably find a link to watch this and find us that way too.
Yeah, always. And then I wanted your coffee talks are every week are they Thursday mornings, right? On LinkedIn? Yes,
Thursday mornings, 8:30 Mountain on LinkedIn.
Yeah, so those are good to drop in and you can hear some things and learn something in a very, they do usually like 15-minute snippets there. It's a good time.
Yeah.
All right, man.
It'll be the longest 15 minutes of your life, I promise you.
No. If you like concrete,
they always last 45 minutes. I keep telling John, we got to quit telling people this is like promoting inefficiency in the workplace across the United States. They think coffee breaks are supposed to last an hour now.
Yeah. No, it goes by fast, especially if you like concrete. So
yeah, absolutely.
Matt, I appreciate you doing this.
Anytime. Thanks for doing what you do, and hopefully we'll get to talk again soon.
Oh, we will.
All right,
for sure.
All right. Take care.
Thank you for joining us for another Concrete Logic podcast episode. If you got some value out of this or you enjoyed it, please share it with others. And if you could take a moment and give us a 5-star review on your favorite podcast listening app, I would appreciate it. We will catch you on the next episode. And now Mike Dunton's going to take us out.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord.